So yes, welcome. Today we'll design dipole antenna with a reflector. So always consider the dipole element will have a height of lambda by 2, and whatever reflector is there, that height will be greater than the lambda by 2, or a driven element we can say. And this is the design formula where lambda equal to c naught by f, and the height is equal to lambda into 0.5. To be exact or precise, lambda into 0.46 you can do. That will be the height. So yes, we switch into the designing now. So file, we have to go to the first file, then new and recent, select the project template, go to the MWRF and optical, select antennas, click on the next, select anything, it is same. We'll go with the waveguide, click on next, select the solver time domain, just cross check these values, gigahertz, nanosecond and Kelvin, click on next. One more thing you need to note down is the spacing between the elements. From dipole to the reflector, the spacing will be lambda by 4. So now we will start the designing. First we'll design the dipole element. So for that we need to select the cylinder here. Press ESC button from the keyboard. Here we can give the name as a dipole. Radius again we will use the parameter called R. It will be minus h by 2 to plus h by 2. Okay, change here material to PEC, that is perfectly electric conductor. Click on preview. Radius is 0.9 mm. Height is the optimized height I'll use directly, which is 128 mm for 1 gigahertz. So we are designing dipole with the reflector for 1 gigahertz. So yeah, this is done. Now we need the excitation for this. So we need some slots. So for that we'll go to the brick. We'll design a parameter called block called the delete. Width will be minus gap by 2, as you all know. On all the axis it will be same. All minimum axis it will be same. And on maximum side it will be plus gap by 2. What is the value of the gap? It is 6.7 mm. So whatever parameter values we are giving, everything will come over here. You can cross check at the same time. H is nothing but the height of the dipole. G is the gap. Sorry, gap is nothing but the gap between the that excitation source. R is the radius of the dipole. Click on OK. Now you can see it has been created. Now what we have to do? We have to subtract this brick from the dipole. So again, go to the navigation. Select first dipole we need to select. Then go to the modeling. Select the boolean. Click on the boolean. Then select the subtract. Then click on this delete operation. Press enter from the keyboard. After you do that, you can see that the gap between both these poles will be created. Now we need to design a reflector. Again, go to the modeling, select the cylinder, press ESC button from the keyboard, rename here as a reflector. Radius of the reflector is same, and height is also minus h by 2 to plus h by 2. Only we need to add some extra thing, extra height on both the axes. Okay, in negative and positive also. You can do by 2. So half will be done on the negative side, half will be done on positive side. One more thing you need to remember is we need to move it at a distance of lambda by 4. Sorry, lambda by 4. Lambda by 4. Here you can use some other variable also. Right now we will use S as a variable for separation. And S value will be equal to lambda by 4, which is 75 mm. E is extra height, which gives you the difference between a dipole and a reflector, which is around 6 mm. So you do 6 here, click on OK. Now you can see here with the distance of S, it has been created. So here S parameter in the description, you can note down as it is a lambda by 4. Okay. H is nothing but height of dipole. E is a parameter which gives you the extra height. Reflector. Okay, that E is nothing but H plus E. Okay, R is the radius of dipole. Dipole or reflector, all are same. This gap is nothing but for spacing for excitation. Now the left out part is we need to excite this. So what you have to do for excitation? First select the center point of the lower dipole. You can see here by zoom in and zoom out, you can do that. Press C from the keyboard. You can get the feasibility of selecting the point, center point. Then double click over here. Then I can zoom out, see the bottom surface of the top dipole. Again, press C from the keyboard, double click on the red portion, both the points will be selected. So that way you can do. Okay, for selecting the point, so for selecting the center point of the circle, we can say precisely, you need to press C from the keyboard. Okay, as both the points are selected, go to the simulation, select the discrete. Once you select that, automatically both the points will be connected with the help of the discrete edge port. Then you can cross check here, impedance needs to be 50, click on OK. Yeah, designing part is done. Now just assign the frequency at 0 to 3 gigahertz, click on OK. Go to the far field, as we need to see the electric field at 1 gigahertz, click on apply. Magnetic field, H field at 1, click on apply. Radiation pattern at 1 gigahertz, click on OK. As all these threes are done, then you can start your simulation. Okay, as I already have the simulated result, I'll show you over here that my antenna is exactly resonating at 1 gigahertz, which give the power value of minus 28.39 dB. Okay, same time you can cross check VSWR also. So yeah, okay, which is below -2, below 2 or 3. 1 is the ideal value. So yeah, we are getting around that. Now we will see the radiation pattern also. So yes, this is the 3D radiation plot. You can see the polar view from here. So there are two different cuts are there, 90-degree cut and 0-degree cut. 90-degree cut look like this, something called dome shape. At one axis it will be more. Second cut is 0-degree cut. So these two cut you can see. So yeah, that's it for designing of dipole with a reflector. Thank you.